Hi everyone, good day wherever you are in any part of the world. My name is Moralake and I'm fondly called Rolly. So, this is the second episode of our series Data Demystification. Last week we talked about data mining, where we explained some of the processes where you say that you are mining data. So today I'm going to be picking on some other terms within the data management profession where people interchangeably use those terms, not knowing the difference between these different terms. And what am I talking about? I'm talking about the AI, the ML, and statistical modeling. So my approach would be to first talk about the difference between the artificial intelligence, which is AI, and machine learning, which is ML. And then I would later talk about the difference between ML and statistical modeling. And then any other thing will go after. So I noticed that a lot of people interchangeably use MI and ML and not knowing the difference. So the artificial intelligence, of course, we all know artificial intelligence is something, a thing, in our world today. And so what is artificial intelligence? Artificial intelligence is a very broad field where a combination of technologies are used to build machines and computer softwares that can then mimic the cognitive capability of human intelligence. And so what do I mean by that? Artificial intelligence is actually built to be able to act like us, like human. What I mean by that is, in terms of our reasoning, in terms of understanding, in terms of, even language processing and things like that. So that's what machine learning is. And so, it's that set of technologies that are built into a computer software, that then give this output. Machine learning, on the other hand, is a subset of artificial intelligence. And so what machine learning is, what it does is it's a set of algorithms that trains from data set and then being able to then produce some kind of results, when you expose another set of data to that algorithm. So what do I mean by that? So when you have a set of data and then you expose your data to those set of algorithms, the algorithm will learn from your data. We call this training. So to train from your data. And so once it trains from your data, the next time you are providing some new set of data to that algorithm, because it had learned from your previous data, it will be able to make predictions or give you some kind of insight into what your new data is, because it has learned from the previous data. And I'm going to give a very simple example also that has nothing to do with these technical terms. For example, now, if last week I tell you I'm hungry, and then you give me rice. And then maybe yesterday I come back to you and I tell you I'm hungry, and then you give me rice again. Today, if I come to you and I tell you I'm hungry, subconsciously, I already know that you're going to give me rice, because there's already a pattern or a trend that's been developed, in that situation. So that's what the machine learning, that's what it does. It learns from your data, and then when you provide new data to it, because that learned from your previous data, then it's going to be able to give you some kind of output that is generated from the trained data that you provided to it. And so the more data you provide to your machine learning, the better it learns from your data. So the connection between AI and machine learning is that AI is a subset. There are so many other things that are so many other combination of tools that AI uses. So MI is just one subset, of which is one of the very common tools, or common tools under machine learning, artificial intelligence. Artificial intelligence. So there are so many many other tools. For example, you have the natural language processing, you have deep learning, you have robotics, things like that. So artificial intelligence is broader. So when people interchange the words, they use MI and AI interchangeably, they're actually making a big error. And so my job here today, my objective is to be able to clear that please, the next time you're talking about AI, you should really be talking about AI. And when you're talking about machine learning, you are really talking about machine learning. And I hope that, just my little explanation has been able to clear, what those misconceptions are. So the second part that I want to discuss is MI, that's machine learning and statistical modeling. I also noticed that people use this interchangeably. And before I jump into that, I'm going to give a little bit of I'm going to tell a little story here. Forgive me. I love to tell stories. That's the part of my work that I enjoyed most. Telling story, being able to tell data story, connecting data, and things like that. And so you would always see me infuse some kind of story into whatever I do. So my background was in statistics. And so, when this whole machine learning AI, started to become a thing, and I started doing my own research, I was confused because I saw a lot of statistics in machine learning, and I was like, okay, so what is this? Are we trying to say that, is this advanced statistics, or are we trying to say that, we can use these words interchangeably and things like that? Until later, when I started, getting more understanding, and then I was able to now see these are distinct tools. They are, even though they are all working on data, they are two different things, or their approaches are different. And so, for anyone that is still in that situation where you are still a bit confused about, okay, this statistical modelings and then this machine learning, what are they really about? Is it the same thing, or you're still using those things interchangeably? That's what my job here today, to clear what these things are. So like I've said before, machine learning is learning from data, directly from data, without any set of rules or programming rules that you would always see, with statistics. So statistics, on the other hand, I don't want to go too much into machine learning because I already explained that. So statistical modeling is actually a bit different from machine learning in that there's some set of rules, there's some set of mathematical based rules or programs that statistical modeling will usually follow. And so when it will follow these rules to be able to make some kind of inference or provide some insights to your data. At the end of the day, what machine learning will give you and statistical modeling will give you may be the same depending on what kind of data you are working on, but their approaches, are a bit different. And you will hear things like hypothesis testing in statistical modeling, where you would first of all have to, maybe you have a theory. Your theory will be, for example, your business problem. You have a business problem that you want to resolve. And so from that, your business problem, you develop some kind of hypothesis. Usually we have alternative, and so we have null hypothesis and the alternative hypothesis. So you need to develop your hypothesis statement, from what your business problem is. I don't want to go too deep into that because this is not a conversation for this is not a technical conversation, so I don't want to go deep into that. But that's the approach that you would always see in statistical modeling. Or you can be talking about sampling and population, where you are using a sample to infer what's going to be happening with the population. For example, I know that people sometimes wonder, okay, so what do they mean when they say that the unemployment rate is 3%? Is it that they actually then gather everybody, or do some kind of survey to know the number of people that are unemployed, and so based on that they're able to tell that, okay, based on the population, this population, only 3% people are unemployed. That's not what happens when they are doing that kind of analysis. So you collect your sample, making sure that the sample has a representation of your population, the old, the young, the demography, everything, all the factors that you always see in your population. Make sure that your sample is a representation of your population. And so based on that, when you have your sample collected and the sample is your population is well represented in your sample, then you can do some kind of analysis that will then infer what's going to happen in your population, because you already have your sample right there. You can say, okay, based on the output of my sample, this is what the population is. And then so you can say the population of unemployed people in America is 3%, and as the case may be. So that's what you do in statistics. So, and that's how it's a bit different from what the machine learning, with how the approach of the machine learning. So I don't want to take our time here. I think we've spent about 10 minutes, which is my target for this video. In our next video, we would also pick on some of these other terms, that we can explain for a general understanding, of what these terms are, so that when you see these things, you understand what they're talking about, and then there's no misunderstanding or misconception of what they represent. So thank you very much. And before I go, for those that may not be familiar with this fabric, this is adire from Nigeria, or well, from Africa, but it's worn by Nigerians a lot. So if you are someone that loves this fabric, you can get in touch with me, and I'll let you know how you can get this fabric. It's worn by Africans. A lot of Nigerians know what this fabric is, and so it can be beautifully sewn. You can different styles. You can make different styles from it, and of course the turban as well is gotten from Nigeria. If you love the turban, you can get in touch with me, and then I'll talk about how we can get it across to you. So thank you very much. Enjoy the rest of the day, and you can look forward to our next video to address some of the other misconceptions within this data management profession. Thank you, and have a lovely evening. Bye.